Hi, so today we'll be discussing Lee Chatler's principle. Alright, so this principle basically deals with the equilibrium reactions. Now the question arises what actually equilibrium reactions are. So these reactions are generally identified with the symbol this one. So this is an equilibrium sign by which the equilibrium reactions can be identified. So let's consider a general reaction A plus B in equilibrium with C plus D. So in this reaction A and B act as reactants while C and D are the products. Alright, so what happens in an equilibrium reaction? The rate of forward reaction is equal to the rate of backward reaction. And when we talk about equilibrium reaction in terms of reactants and products, so what happens? The rate of consumption of reactants become equal to the rate of formation of products. Alright, so this was all about equilibrium reaction. Now talking about the Lee-Chatelier principle. So the principle states that whenever any change is done in an equilibrium reaction, the equilibrium will tend to shift in the direction that counterbalances the change. Alright, now talking about the changes can be in the change in concentration, it can be the change in temperature, it can be a change in pressure, and also it can be a change in volume. Now we will consider the effect of each change on the equilibrium direction. So first of all we'll study the change in concentration. Alright, consider a general reaction A plus B in equilibrium with X plus Y. So here A and B act as the reactants while X and Y act as the products. Alright, now let's suppose the concentration of reactants is increased. Alright, so basically we are increasing the concentration of A and B. Now what will happen as per the Lee-Chatelier principle? The equilibrium will shift in the direction where the reactants are getting consumed or the concentration of reactant is getting decreased. And if we look at the reaction, the forward reaction is that reaction in which reactants are getting converted into products. Thereby the concentration of reactant is getting decreased. So whenever we are increasing the concentration of products, the equilibrium will shift in the forward direction or towards the product side, or you can call it towards the right side. Now similarly, if we consider that there occurs an increase in the concentration of products, so when we are increasing the product concentration, now look at the equilibrium reaction. Again, the products are getting consumed in the backward reaction since they are getting converted into reactants in that particular reaction. So what will happen if we increase the concentration of products? The equilibrium will tend to shift in the backward direction, or towards the reactant side, or you can call it towards the left hand side. Next, we are going to discuss the change in temperature. Let's take an example of a reaction where gaseous N2 is reacting with gaseous hydrogen, and that is in equilibrium with gaseous ammonia. In this particular case, the forward reaction is exothermic and the backward reaction is endothermic. Now the question arises, what are exothermic and endothermic reactions? So exothermic reactions are those reactions in which energy is being released. Alright. And endothermic reactions are those in which energy needs to be supplied. Alright. Now let us consider the effect of increased temperature. Now what will happen if temperature is increased? Equilibrium will tend to shift in the direction of endothermic reaction. Why so? Because endothermic reaction makes use of temperature, thereby counterbalances the effect of increased temperature. Similarly, if we decrease the temperature, the equilibrium will shift in direction of exothermic reaction. Next, we'll discuss the change in pressure. Let's consider an example where gaseous nitrogen is reacting with gaseous hydrogen, that is in equilibrium with 2 moles of gaseous ammonia. Alright, so what happens in this case? In this particular reaction, all the reactants as well as products are present in the gaseous phase, as you can see from here. Alright, so all gases exert some amount of pressure on the system. So let's take an example when we are increasing the pressure of the system. Now if we look at the reactant and the product side, we can see on the reactant side there are 4 moles of gases. Alright, and on the product side we have only 2 moles of gases. Now what will happen if pressure of the system is increased? Equilibrium will shift in the direction in which number of moles decreases. Why so? Now what will happen? Less number of gaseous moles will exert less pressure. Alright, so thereby counterbalances the change. Similarly, if we decrease the pressure, equilibrium will shift in the direction in which number of moles increases. That means in that particular case, if we increase the pressure of the system, the reaction will shift in the forward direction because number of moles are getting reduced here. And if we decrease the pressure of the system, equilibrium will shift in the backward direction due to increase in the number of moles. Next, we will consider the change in volume. Now what will happen if volume of the system decreases, its pressure will increase, and therefore equilibrium shifts to the direction in which number of moles decreases. Similarly, if volume of the system is increased, its pressure will decrease and equilibrium shifts to the direction in which number of moles increases. Thank you and have a nice